Hello everyone and welcome back to Mathematical Mindset. So right here in today's video in the series of matrices, we want to simply talk about the determinant of a matrix. How you can find the determinant of a matrix. Now the determinant of a square matrix is a scalar value that provides important properties about the matrix, such as whether it is invertible or singular. Now in our previous video, we talked about special matrices and their properties, and we find out that in some special matrices such as upper triangular matrices and diagonal matrix, it was said that if we multiply the diagonal elements, it is the same thing as when you find the determinant, alright? And we also said that when we talk about the identity matrix, we talked about that if you find the determinant of an identity matrix, it is always 1. So in today's video, we're going to prove if that is actually true. And the determinant is denoted by det A, or the absolute value of A. So you can easily denote your match determinant using this format or this format right here. Now determinant of a 2 by 2 matrix. For a 2 by 2 matrix, if you have a matrix A, B, C, D, in order for you to get the determinant, all you have to do is to multiply diagonally, which is you multiply A to D and you multiply B to C. That is all you have to do in a 2 by 2 matrix. So we have that A to be equals to AD minus BC. And once you do that, you have been able to find the determinant of a 2 by 2 matrix. Alright, so let's take a look at these examples right here. Find the determinant of the following 2 by 2 matrix. So we have this right here. So we say that A is equal to, so we're going to multiply these two, which is 1 times 1 minus, then we multiply this one 0 times 0. This is equals to 1 times 1 is 1 minus 0 times 0 is 0, and this is equal to 1. So the determinant of the matrix A is 1, and we have been able to prove that if you find the determinant of an identity matrix, it is 1. Now this is an identity matrix of a 2 by 2 matrix. So we find the determinant. As you can see, the answer is always what? 1. Now the second question says if we have a matrix B equal to 1, negative 1, 3 and 2. So to find the determinant of B, all you have to do is to multiply diagonally. So you multiply 1 times 2 minus negative 1 multiply 3. So we have 1 times 2 to be 2 minus negative 1 multiply 3, we have negative 3, which is equals to 2 minus times minus is plus 3. So this is equal to 5. So the determinant of this matrix is 5. And lastly, the last example for a 2 by 2 matrix. So find the determinant of this. We want to simply multiply diagonally. So if you multiply these two, we have this to be 4 times 9, subtracting, multiply this diagonally, we have 7 times 2. So the determinant of E is equal to 4 times 9 is 36 minus 7 times 2 is 14. So this is equal to 6 minus 4, 2, 3 minus 1, 2, and this becomes the answer. So this is how you can easily find the determinant of a 2 by 2 matrix. Alright, so for solving for the determinant of a 3 by 3 matrix, now we have a matrix A to be A, B, C, D, E, F, G, H, I. So the first thing guys you want to note is that each of these elements right here has a sign. Alright, so this first element right here carries a positive sign, this element right here carries a negative sign, and this element right here carries a positive sign. Also, this element right here carries a negative sign, this element carries a positive sign, and this carries a negative sign. This carries a positive sign, a negative sign, and a positive sign. Alright, so each of this element and the signs they carry is very important, especially when finding the cofactor of a matrix. We are going to talk about that as time goes on. Alright, so guys, in order for us to be able to find the determinant of a 3 by 3 matrix, those symbols right here at the top is very important because we are making use of the first 3 elements right there, which is A, B, and C. Alright, so in order for us to be able to get this right here, how were they able to get this answer? I'm going to share with you how that was done. Alright, so the first element right here is carrying a positive sign, so we bring out plus A. So for the first element A, this implies that the first row and the first column is out. So if the first row and the first column is out, we have this to be E, F, H, I. Alright, Then we go to the second element, which is negative b. The column of b is out and the row of b is out, so we are having d, f, g, I to be left, plus c into the element of, now for c, the row and the column that belongs to c is out, so we have d, e, g, h to be left. So from here we want to apply the 2 by 2 matrix, so we have that a is into e multiply I minus f multiply h, which is fh. That is, this is multiplying this and this is multiplying this, so we have minus b into di minus fg and plus c multiply dh minus eg. Alright, so this is how this answer was gotten, right? Sorry, this is supposed to be E and not C. Alright, so this is how we're able to get the determinant of A. So from here, we're going to walk through different examples in order for you to be able to understand how to find the determinant of a 3 by 3 matrix very well. So right here we have the first example, and right here this first example is an identity matrix, a 3 by 3 identity matrix. And on our previous video on special matrices, we talked about identity matrix, and one of the property of identity matrix is that the determinant of an identity matrix is always 1. And I said I'm going to prove that using this video right here. Okay, so this is it right here. So we have the first element to be plus, minus, and what? Plus. So from here we have this to be plus 1 into, so the row and column that belong to 1 is out, so we have 1 0 0 1 left, which is to say this is out and this is out. So we go to the next one, which is minus 0 into, so from here we have that the whole of this column is out and the whole of this row is out, so we have 0 0 0 1 plus 0 into, so which implies that this is out and this is out, so we have 0 1 0 0 to be left. So we have plus 1 multiply, this is going to multiply this, which is 1 times 1 minus 0 times 0, minus 0 into 0 times 1 minus 0 times 0, plus 0 into 0 times 0 minus 1 times 0. So we have this to be 1 into 1 times 1 is 1 minus 0 times 0 is 0, minus 0 into 0 times 1 0 minus 0, plus 0 into 0 minus 0. So we have this to be 1 into 1 minus 0 is 1, minus 0 plus 0, so this is equal to 1. So we have been able to prove that the determinant of an identity matrix is always 1. So this is how you can find the determinant of a 3 by 3 matrix. Let's take a look at another example. So we have this example right here, so we want to find the determinant. So the first thing we want to do is to put in our sign, which is plus minus what? Plus. So we have this to be plus 3 into, so if you take out this and take out this, we have 0 negative 2 1 1 to be left, minus 0 into, so here is out, so we're taking 2 negative 2 0 1, plus 2 into, so we have here is out, so we have 2 0 0 1 to be left. So we have 3 multiply 0 times 1 is 0, minus negative 2 multiply 1, we have it to be negative 2, minus 0 into 2 times 1 is 2, minus 0 multiply negative 2 is 0, plus 2 into 2 times 1 2, minus 0 times 0 is 0. So we have 3 into minus times minus, this is going to give us plus, so 0 plus 2 is 2, minus 0 into 2 minus 0 is 2, plus 2 into 2 minus 0, we have it to be 2. So from here 3 times 2 is 6, minus 0 multiplied 2 is 0, plus 2 multiplied 2 is 4. So we have 6 minus 0 6, 6 plus 4 is going to give us 10, and this becomes the answer. And lastly, we have this example right here and want to find the determinant. So to do that, we give this our sign, so we have plus minus plus, so this becomes plus 5 into, so here is going out and here is going out, so we have 4 7 8 9, minus 3 into, so here is out and here is out, so we have 2 7 6 9, plus 1 into, here is out, so we have 2 4 6 8. So we multiply, we have that 5 into 4 times 9 is 36, minus, so we have 8 times 7 to be 56, minus 3 into 2 times 9, 18, minus 7 times 6 is 42, plus 1 into 2 times 8, 16, minus 6 times 4 is 24. So from here we have that 5 is going to multiply 36 minus 56 is negative 20, minus 3 into 18 minus 42 is going to give us minus 24, plus 1 multiply 16 minus 24 is going to give us minus 8. So we have 5 times negative 20 is negative 100. Minus times minus is plus. 3 times 24, so we have 24 times 3. This is 12, carry 1. 3 times 2, 6 plus 1 is 7. So we have this to be 72. So we have plus times minus is minus. 1 times 8 is 8. And this is equal to minus 36. And this becomes the final answer. So guys, these are everything you simply need to know in order for you to be able to find the determinant of a 2 by 2 matrix and a 3 by 3 matrix. So guys, if this video is really helpful to you, please do not forget to leave a comment below and give this video a thumbs up. And with this guys, I'm going to see you in the next video.